So this is trying to find the area of something like this is what we were doing this week in class, so maybe I'll do one of those. The key to doing a problem like this is cutting into triangles. It doesn't matter what the shape is, you're just trying to cut it into triangles. And the key thing to understand is that all of these are going to be the same. Each of these 5 triangles that I've made is identical, which is sort of part of the point. Because if I can have these 5 identical triangles, all I have to do is figure out one of them, right? So the way we do this is there's a special formula that you can that I taught for the area of a triangle when you don't have the base or the height. You know, when you're a kid and you learn the area of a triangle, you know, you find the base, you find the height of the triangle. Well, we don't have that. So what you can do is, if you've got a triangle and you know 2 sides and the angle in between, you can just get a different formula here. So if I knew side A here, I knew side B here, and I knew the angle X in the middle, let me put a little angle sign here. Angle degrees. So A, B, and X degrees. I can get a formula for the area of the triangle that is workable. So, you know, your side A, your side B, and then the sine of this angle right here. And sine, for those of you who are not in my class, sine is just a function on your calculator. We talk about how to find sine, but really it doesn't matter. It's just you type it into the calculator and the calculator will put it together for you. So what we need is information. And well, let's start out with something easy. Since all of these are the same, that means that whatever A is, B also has to be. So let's call A some amount. Let's call A, I don't know, 10 meters. So the length of this side is 10 meters, which means this also ends up being 10 meters. And the only thing now we need to do in order to figure out the area of this triangle is we've got A, we've got B, we just need X. And all 5 of these angles are the same, right? So they all make 360 together because they sort of go around a circle like that, right? So if I did 360 divided by 5, I had better get 72, right? And so we end up with this information here. We've now got A, we've got B, and we've got X. And the great thing about doing this problem this way is that I'm working with a pentagon. I could be working with a hexagon, an octagon, whatever. But every shape, this number here is going to be the same. For every pentagon, you don't need to reinvent the wheel. You can say, hey, this is 72 all the time. For For every octagon, if you divide, you're going to see that every angle here is going to be 45. So you only really have to do it once, this middle angle here. If you know what the middle angle is for a pentagon, you can just figure it out. So we can just plug these in now. And get an answer. This is not something that you're going to be able to just do in your head. If it were me, I would just plug it into the calculator. 1/2 times 10 times 10 times the sine of 72 degrees. And when you do that, you end up with this number right here. And that is one of these triangles. That's in meters squared. That's one of these triangles. You only found one of these triangles, but how many triangles are there? One, two, three, four, 5 of them, right? So if we're going to find the whole thing, we better do times 5. Just do times 5. And I've already got the number saved in my calculator. Let's do times 5. And so the whole thing here is going to be, so one of them is 47.55 something, and I want all 5 of them. So I'm going to multiply by 5, and I get 237.764129, and that number keeps on going as you go through. But when you are doing this problem, you're going to be told, round it to a certain amount, because we don't want to just leave this whole messy decimal here. We want to have our answer nice and neat so that we can present it. And so usually they'll say something like round to the nearest tenth. The nearest tenth, we're talking about the nearest 1 decimal place. So I'm going to make a little mark right here. So here's 1 decimal place, so I'll look at the next one. I say, well, that's a 6. Well, that's 5 or bigger, so we know that it's closer to the next one up than it is to the one previous. So instead of leaving it as a 7, we're going to round this up to 0.8. And then our units for length were meters, but since we are talking about area, we want it to be a square unit, meters squared. And this would be our answer right here. So this is the problem. There's one piece that is important that is missing, and that is this. So this is the regular polygon that they're talking about right here. And we want to know what's the area of that regular polygon. So we've got a lot of options, to be very honest with you. It really depends on which way you prefer. In this one, you don't have to use trigonometry. And the reason you don't have to use trigonometry is because this is a hexagon. Whenever you have a regular hexagon like this, we're going to do the same thing that we do with all the other ones. The only difference is that when we do it, we're not going to have to use trig because we've got a special thing for our regular hexagon, and I'll tell you why right now. So regular hexagon, these triangles that I cut it up into are equilateral. And that means that I'm going to draw a little triangle right here so that we can do some work on it. Try to make it as equilateral as possible. And so the thing of it is, let's move you down here. Let's move you over here so we can see. The thing about this right here is that equilateral triangles each have angles that are 60 degrees all over. So why this is important is because since this is 5, well, all these are 5, right? 5 meters, 5 meters, and 5 meters. And basically what it boils down to is I can take this equilateral triangle, slice it down the middle, and make a 30, 60, 90 triangle. So this whole thing is 5, so this piece is 2.5, which means that this piece right here is 2.5 radical 3. So I've got my base is 5, my height is 2.5 radical 3, basically whatever the base is for this equilateral triangle, cut it in half, put a radical 3 on it, there's your height. And now I can just do my problem, find the area of one triangle, 1/2 base height. And then from there, this is one triangle, and I just want all 6, right? So you're going to take 1/2 times 5 times 2.5 radical 3 in your calculator, come up with what that is. I've got mine right here. Because they want it rounded to a decimal place. So we can forego trying to keep everything exact and just get us a big decimal, because that's what they want anyway. 1/2 times 5 times 2.5 times the square root of 3. And so when we do this right here, get this one triangle, has a measurement of 10.82531.755. And then to answer your question, why would you multiply by 6? Well, I just found one right here, right? But how many this is one of those, right? How many triangles are there? 1, 2, 3, 4, 5, 6 triangles, right? So since I know that I can find one of them, I don't need to go back and do each of them, right? I just do one, and then, hey, there's 6 of them, so times 6. Does that make sense? So we take this, we times 6, and then whatever we get, we want to look at the directions because it does say round to 1 decimal place, and that's why I did put it as a decimal here. You don't have to. You could leave it as 6.25 radical 3, I guess, or 25 over 4 radical 3, but they want it as a decimal, so there's no reason to do gymnastics up here. Just throw it into the calculator, make it ugly, and then round it the way that they want it to. So I've got my 1 triangle. My whole thing is 6 triangles, so let me just times 6. And the whole thing is approximately 64.9519 0528. And then I want to round, what does it say, to the nearest 1 decimal place, the nearest tenth. So here's my tenth, so I look at the next one. This is a 5. Well, 5 and up, I make this one bigger. 64.9, the 9 rounds up, and we get 65.0 meters squared, and that's what will go into the box right here, 65. The point zero, like if we're doing significant figures, we would say 65.0 because it's to the 10th, but 65.0 and 65 give you the same thing. Yes, actually, we'll always have a radical 3. Like this thing up here will always be, so whatever the length of the side of the triangle is for our equilateral triangle, if this is 5, cut that number in half, put a radical 3 on it. So I'm gonna show y'all. So if you go through, and I'll go back to that problem so that you can see it better. But here's my equilateral triangle again. So it doesn't matter what the length of the side is. It could be 50, it could be 10, it could be X. If this side here has a length of X, the height, the perpendicular going straight down here like that, the height will always be X radical 3 divided by 2. So what I would do is I would just take the X, cut it in half, put a radical 3 on it. Right? You get what I'm saying with that? So if this is 50, this will be 25 radical 3. If this is 90, then this will be 45 radical 3. This is 12. This one up here will be 6 radical 3. It's basically just take this number, divide it by 2, put a radical on it. And if it's an odd, ugly number, then we can suffer with that. If it's like 13, then this is going to be 6.5 radical 3. So just whatever this one is, divide it by 2, put a radical 3 on it, then you're done. And that'll get you the height of the triangle given the base, as long as this must be equilateral. That's a U. Alright, this must be equilateral in order to be able to do this. It's because you can take the equilateral chop it down the middle and make two 30, 60, 90 triangles, going from the small side of the 30, 60, 90 to the medium side is times radical 3 every time. Alright, so first things first, with this one, the thing that's gonna make this a little bit different than the one we were just doing is that we don't have equilateral triangles to work with. Octagons don't make good 30, 60, 90 triangles, but we can still put all this together. Let me make the... well, let me do the thing, please. There we go. So here's my octagon, and I've cut it into the triangles. And what we need to do first is get this middle angle, because what we're going to have to do is we're going to have to use the 1/2 AB sine x formula to find the triangle. So we're going to go through, we're going to count. We got 1, 2, 3, 4, 5, 6, 7, 8 triangles to work with, and together all these central angles make 360. So we're going to say, hey, here's 360 divided by 8, and that is 45, right? So that is x. X is 45. And what we need to do from here is we need to actually figure out the radius so that we can do A and B, right? So let's circle this, put it to the side. We're going to need that for this. Now we've got to find A and B. And the way we're going to do that is we're going to say, okay, yeah, I've got this, but I don't want that. I want this up here, right? I want that. I want our A and our B so that I can get my answer. Since this middle little angle is 45, what we're going to do is we're going to take that triangle, we're going to cut it in half, and we're going to make a right triangle. Just like I showed you in the video from earlier, we can use this right triangle to figure out the radius. So this is our radius. This is A. That's what we're trying to find. Here's our 90-degree angle. And then this right here, you know, we took it and we cut it in half. So the whole thing is 18, but this piece right here, this is 9, right? So there's 9. This is our A. And then the angle gets cut in half too. So the side gets cut in half, the angle gets cut in half. So we're going to cut in half this 45 degrees. Half of 45 is 22.5. And so now we're going to look. Well, we've got the opposite. We've got the hypotenuse. So we are going to use sine. So sine of 22.5 equals 9 over A. And then when we can solve, we're going to make our proportion, cross multiply and divide. And when you do that, you end up with our A is actually 9 over this whole sine of 22.5 thing. This is our radius. We just found it. So now we know A and B. I would just do this in the calculator right now. Get a big long running decimal to plug into the calculator and deal with that. So let me do that real quick. So we've got 9 divided by the sine of 22.5, and that's going to come out to be something ugly, but it is what the length of the hypotenuse is here. So it ends up being 23.5181337. And you're going to end up using this number. This is A and this is B. This is also A and B, both of them, right? They're both the same. So you're going to take that, you're going to put it in here, 1/2. For one triangle, we got one triangle. Now we're literally doing exactly what we were doing here, finding our one triangle and then multiplying to get the whole thing. Just now we're going to do it using our 1/2 AB sine x formula instead of using 1/2 base times height. So one triangle is going to be 1/2 times this 23.5181337 number. And since they're both the same, what you could do if you wanted to be lazier, which I fully understand, since they're both going to be the same anyway, you could instead of multiplying this and then writing it all over again to multiply it again, you could just square it, right? It's just the same thing times the same thing is squared. And then sine x. And we have to go back here. This is what we found for x like 15 years ago, right? So sine of 45. This is one triangle, and you're going to throw that into the calculator. You're going to find out what that is, and then, well, there's how many triangles? 1, 2, 3, 4, 5, 6, 7, 8 triangles. So once you figure out what this is, you're going to multiply that by 8, and that'll be your final answer. And again, you're going to look here, and it's going to say round to the nearest whole number. So make sure you're going to look at the 10th and see, do you bring that up or down, right? So, let me see. So it's like 1/2 times that 23.5181337 number squared times the sine of 45. That's one triangle that is 195.551298.6. And you notice I am not rounding here. I'm leaving this alone. I'm not doing anything to this number yet because I'm not done with it. That's one triangle. So now I want the whole thing. I want the whole thing. And the whole thing is 8 triangles. So I'm just going to take this, I'm going to times 8. When I multiply by 8, here's what I get. I get 1,564.410389. And now this is the whole area, right? This 1,564.410389. And then from here, I need to round. I need to round to the nearest whole number. The nearest whole number is here, so I'm going to put my line right here, and I'm going to look at this number right here. That's a 4. That is less than 5. So this rounds down, and my final answer that I put in the box is 1,564 centimeters squared. So, like, for example, here's the first problem. And what we need to be able to do is figure out the area of this thing. Nowadays, since we don't have a base and a height, we're going to have to use the formula that I gave on the YouTube video that I put out last week, I think it was. But the formula here is 1/2 times side A times side B times the sine of the angle X. It looks like I am, hopefully it didn't just like jump in your feed. I had a little scrolly doohickey for a while. So here's, you've got your angle X, you've got your side A, you've got your side B, and so basically you're just going to go in and you're going to put those in. Well, what's A? A is 3, right? What's B? Well, B is 6, right? And what's X here? X is 44. And then after this, literally all you do is you're going to plug this into the calculator and follow the directions in blue. For this problem, it's going to tell you round to the nearest square inches needed. So like for me, with my numbers that I have, I take it and I plug it all into the calculator, and what do I get? I get, once I get there, so I'm just going to take the 1/2, the 3, the 6, the sine 44, multiply them together. So 1/2 times 3 times 6 times the sine of 44. And you end up with a number like this. 6.251925334, and it goes on. That's just what the calculator displays, but it's going to keep going on forever with that. But we don't really care about that so much. We just care about what they tell us to round it to, and they tell us to round it to the nearest whole number, the nearest inch, right? The nearest square inch, because we're talking about area. So here's in square inches. We're rounding to the nearest whole inch. So look, we look at this 2 and we say, all right, well that is not 5 or more, so we're going to cross that whole thing out. And what are we left with? We are left with 6 inches squared for our final answer. You'll notice, for the answer blank, let me cut a picture here so y'all can see what I'm talking about. You notice for what they give you, let me move this out the way, down here, they give you the inches squared, so don't put inches squared in the box. For me, since these are my numbers, this is my answer, when I type it in, I can just put the number 6, because they want us to round to the nearest square inch. Now, this is a very important direction right here. Do not round until the final answer. There's going to be some problems where they're going to say, hey, you have to do like a bunch of different steps, and then you're going to be tempted to like round in the middle. Don't do that. Keep the big long decimal until the very end, and then finally round there. So let's see. That formula was just find the area of a regular octagon with a side length of 18 centimeters. Okay, so you want a regular octagon with a side length of 18 centimeters. Let's do that. That one, we're actually going to end up using this formula again, and I'll show you how you're going to do that. But there's a couple extra steps in the middle. So let's make an octagon. I can do that. I can make an octagon. There's an octagon. And you said that the side length is 18, right? So the thing that we're going to have to deal with is we want to be able to do like what we did last week. We want to be able to take the triangle and find the area of the triangle, and then since there's 8 of them, right, if I just connect the dots to the middle here, it's looking ugly, but that's okay. We see that there's 8, right? There's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. So if I can just find one of these triangles, just like we did in the last one, then from here, all I have to do is just multiply whatever I get for that by 8. Makes sense, right? So in order to do that, we need the things that we had in the last problem. We need the 2 sides and the angle in between them. So, I guess the easiest thing to find first is the angle in the middle. You know, you look here and you've got all these slices, and each of them are the same, and together they make a full circle, right? A full circle is 360 degrees. Each of these is the same, and there's 8 of them. So what we can do is to find this angle in the middle, we can do 360 divided by 8 to get that angle, which if you do that, 360 divided by 8 ends up being 45. And what's really great about this method is that if you're doing an octagon, it's always going to be this number 45, right? Because all the octagons are going to be the same, just, you know, shrunk up or scaled down, but it's still going to be 45. So if you have a pentagon, if you've got 5 sides, that the 5-sided one is always going to have that central angle thing be the same as well. It's always going to be 72. Or, you know, if you've got a 10-sided figure, it's going to be 36 degrees. It's always going to be the exact same thing. So this is the number when we're doing our formula here. This is what x is going to be. So we've already got x, right? So this is our x. So now the next thing you have to deal with, is trying to figure out these guys here, because you want to use these guys up here, these lines, because they're the same. You know, this is, you know, if this is your A and this is your B, and you've got your X in here. If you know what these two are, you only have to find one of them because they're the same, and you've already got your 45. So basically, we only have the one step left to do. So the easiest way to do that is to use your basic trig. So if you go through, what I'm going to do is I'm going to try and figure out what this piece is by drawing a little line down here, making myself a little right triangle, and then figuring it out. Let's take this triangle and sort of blow it up so you can see better what I'm talking about. Yeah, exactly. You're exactly right. So whatever shape it is, it's, you know, basically we're always working with a circle. It's just, you know, instead of having it be smooth all around here, there's 8 sides to it. So you can think about it that way, and you'll always be fine. Absolutely. So let me show you what this triangle has going on here. Let's see if I can make a triangle so it doesn't look so ugly. Hey. So here's what we have. This whole thing is 45, right? And we want to find the radius of the octagon so that we can just put it up into our 1/2 AB sine x and be done. So what we have to do is we have to basically take this, slice it in half. So we're going to take this right here, and we're going to make half of it. We're going to basically take this boy right here, slice it down the middle. This whole thing is 18, just like up here. And since the whole thing's 18 and we're slicing it in half, now it's 9, right? You go through. This whole thing was 18. We sliced it in half, so now we have 9. This is the thing that we're trying to find. And just like we sliced this here, we're going to slice this here. Half of this 45, 22.5. So now we've got the opposite side, we've got the hypotenuse side, so we know we're using sine. And the great thing about this is since we're finding the side here, from the side, we're always going to use sine. So you don't have to like think real hard. You can just say, okay, well, I'm always using this one, so it's always going to be sine. And then opposite over hypotenuse, 9 over x. Cross multiply and divide, you end up with the radius that you want, 9 over sine 22.5. This you can put in the calculator, but remember the directions. Don't round early, because if you round early, you're going to end up with error in your answer, and you don't want that. So you go through. This is your A and your B. Both of them are whatever this is. And so now from here you've got your angle, you've got your radius. You can just plug that in, and then once you find one triangle times 8, you've got 8 of them, right? So let me show you what I mean. Let me pull up my calculator, because again, this is not something that you can do in your head. It's difficult. So you go through. The area of one triangle is 1/2 times this thing, 9 divided by sine of 22.5, which I'm going to, because I don't have a lot of space right here, I'm going to abbreviate it. But it's like 23.5 something, 1/8, yada yada yada. That's your A, right? This. And then your B is the same thing, 23.5 something times the sine of the angle of the triangle, this guy right here, the x, the 45, this guy, right? Times sine 45. I got you. I'm gonna finish writing this down, because basically once you do this, you just plug it into the calculator. Hopefully everyone is doing the social distancing thing and washing your hands. For next week, will you still have this for the Monday, Wednesday, Friday schedule, or just in the 25-minute class period? So the way that I'm going to do it is I'm going to be streaming daily, Monday, Tuesday, Wednesday, Thursday, Friday, 9 to 11, and 11:30 to 1:30. I think that's what I have written down. Wait, hold on, let me check. But that's what it'll be. I'll have those. The only day that it won't be like that is Thursday, because I have meetings. On Thursday, I just won't have them in the morning. But, where did I put it? Yeah, 9 to 11 and 11:30 to 1:30 daily, Monday, Tuesday, Wednesday, Thursday, Friday. Thursday is the one day where it'll be like in the morning. I either will do it a little bit earlier or I won't do it, depending on how busy the day is. But I'm always also available via email. Hold on, here's my email. I'll write it down. With our normal And so if you have any questions and I'm not in the middle of streaming, or you want to make sure that you get queued up for the beginning when I do stream, send me an email. If you give me emails in advance, I'll have them prepped up here and I'll run through them.